Welcome to Sanjay Godavat IIT and Medical Academy. My name is Uday Shankar. I am now going to teach the motion in a plane. See, motion in a plane means it has two coordinates. Its motion can be defined with the help of two coordinates. The motion in which two of the three coordinates x, y and z. Actually in space there are three coordinates x axis, y axis and z axis. Any of the two x or y coordinates are changing with time. X and y or x and z or y and z, they are changing with time, then that motion is called as two-dimensional motion. Actually, simultaneously the motion to be changed. Two coordinates at any time, two coordinates to be changed. For this point, suppose whenever it comes to point B, here x2, y2. For a time, particular time, here coordinates are x2, y2. For another time, x3, y3. In this way, when it comes to this point x4, 0. So, the coordinates are changing with time. Two coordinates to be changed with time, then that motion is called the two-dimensional motion. Projectile motion. Motion can be along x-axis or along y-axis, but that motion should be under gravity. That is called projectile motion. Oblique projectile. Oblique projectile means this angle of projection, body is projected in this way, body is projected in this way by making some angle theta. Theta should be between 0 degrees and 90 degrees. Then the projectile is said to be oblique projectile. Theta is 0, it is a horizontal projectile. Theta is 90 degrees, it is a vertical projectile. Theta is lying, suppose theta is between 0 and 90 degrees, this is oblique projectile. It has some angle. This initial velocity has some angle with x-axis. Then it is called oblique projectile. See, I am projected a body by making some angle theta with x-axis with velocity u. This velocity can be resolved into two components. Where theta is there, that is u cos theta, that is horizontal component, it is represented with ux. Where theta is not there, that is vertical component, uy is equal to u sin theta, it is along y-axis. Here, there is no force along the horizontal direction. If air resistance is neglected, there is no force along the horizontal direction. So, along this direction, force 0 means force is equal to ma, force is 0, then acceleration 0. But vertical direction, there is a gravitational force downward direction. Due to that gravitational force, it will get an acceleration that is equal to acceleration due to gravity. It is minus g because it is downward direction. Minus g. Upward direction velocity is u sin theta. Acceleration downward direction, so minus g. Force direction is nothing but acceleration direction. Now, after t seconds, body reaches this point. There its velocity is v. This velocity is making an angle alpha with the horizontal. This v has two components, Vx and Vy. To find out Vx, I am applying the formula V is equal to U plus AT. But Vx I want, so Vx is equal to Ux plus AXT. But Ax is 0. So Ux is equal to U cos theta because this term is equal to 0. So Ax is equal to 0. So Ux is equal to, you are getting U cos theta. Now Vx is equal to U cos theta. Now along vertical direction again I am applying this formula V is equal to U plus AT. But I am taking along vertical direction Vy is equal to Uy plus Ayt. So Uy is equal to U sin theta, Ay is minus g. If I am substituting these two in this equation, Vy is equal to U sin theta, Ay is minus g into t. Then resultant velocity at this, if you know two components of the velocity, you can find out that velocity. In vectors we know that v equal to root of vx square plus vy square. Vx is u cos theta, vy is u sin theta minus gt whole square. So I am simplifying this one, u square cos square theta, and I am expanding this one, u square sin square theta plus g square t square minus 2u sin theta gt. But u square cos square theta plus u square sin square theta, I am writing u square because cos square theta plus sin square theta is 1. So remaining here g square t square is there minus 2u sin theta gt. So velocity at any time we can calculate. Velocity at any time, when a body is projected, it reaches this point. Its velocity is different from this velocity because it is under acceleration. Now here velocity has two components. That components are determined here and that velocity be determined here. So this velocity is making some angle alpha with x-axis. That alpha also we can calculate. Tan alpha is equal to Vy by Vx. Vy already we have. Vy is equal to u sin theta minus gt. Vx is equal to u cos theta. I am substituting this value. From this, we can find out the alpha value. Alpha value is tan inverse u sin theta minus gt by u cos theta. So, at any time, velocity of the body can be calculated. Now, body is projected. This is x-axis, this is y-axis. Body is projected in this way. Now, this body reaches this point. This is vertical displacement. This is horizontal displacement. This is the displacement of the body. Suppose I want to find out here velocity. Previously we determined at any time velocity. Now at any velocity of the projectile at a vertical displacement y, we have to calculate. For this, we have to use the displacement. This is horizontal displacement. Sx is equal to x. Sy is equal to y. I am using the formula Vx square minus ux square. Actually, v square minus u square is equal to 2as. So, as xx. Then, Vx square, ux is u cos theta whole square. 2, ax is 0, sx substituted. But ax is 0 along the horizontal direction, acceleration is 0. So, Vx is equal to u cos theta whole, Vx is equal to u cos theta, you will get, because this square will cancel. Similarly, y direction, along y direction, its displacement is sy. I am writing that, actual formula I am writing v square minus u square is 2as, but ay. So, while using this one, vy square minus uy square is equal to 2aysy. Vy square minus uy is u sin theta whole square, 2 into ay is minus g, sy is y. I am substituting that. Then vy I got. So, I got here vx, that vx is u cos theta I got vy I got as root of this value u sin theta whole square minus 2gy. So, once you know Vx and Vy, you can find out the velocity. V is equal to root of Vx square plus Vy square. If you substitute these values, then Vx is u cos theta whole square, Vy is equal to, here Vy is equal to, if you substitute root of u sin theta whole square minus 2gy whole square, then u cos theta whole square plus u sin theta whole square minus 2gy. Then simplified, v is equal to u square minus 2gy. That is the velocity. Velocity at any vertical displacement y can be calculated. Again, I am applying horizontal direction. Yes, in horizontal direction, I am applying this formula Vx square minus ux square is equal to 2ax sx. Vertical direction, I applied the formula Vy square minus uy square is equal to 2ay sy. You have to remember here. What we have to remember? Along this x direction, velocity is u cos theta. Along the y direction, velocity is u sin theta. Along the x direction, acceleration 0. Along the y direction, acceleration is minus g. Now, at highest point, when body reaches at a highest point, body reaches the highest point, highest point meaning vertical component of velocity 0, total velocity along the horizontal direction. Total velocity is along horizontal direction. In horizontal direction, always velocity is constant u cos theta, because there is no acceleration along the horizontal direction. So, here velocity u cos theta, that will be continued. Any point, there is no need to calculate always. At any point, horizontal direction velocity is u cos theta. But vertical direction, velocity changes with time due to acceleration, due to gravity. Now, at highest point, the velocity is in this way, acceleration is downward. The angle between them is 90 degrees. Angle between them is 90 degrees. So, you know that vertically projected body, completely vertically projected body, at highest point velocity is 0. But in oblique projectile, at highest point velocity is not 0, only vertical component of velocity is 0. There is horizontal component of velocity that is equal to u cos theta. Okay, you can write these velocities into vector form. Initial velocity u I can write in the vector form along the horizontal direction. Velocity is equal to u cos theta. Along the vertical direction, velocity is u sin theta. So, initial velocity in vector form is u cos theta I cap. Vertical direction u sin theta j cap. But we know that whenever it reaches this point, velocity is v bar, but u cos theta same, because along the horizontal direction there is no acceleration, but vertical component u sin theta minus gtj. This is the vector form of velocities at any time t, and initial velocity you can take in this way. Now, time of flight. What is the time of flight? The amount of time spent by a projectile in air is known as time of flight. Body is projected, it started here, it comes here, how much time it takes to come to this point is called as time of flight. At this time of flight, vertical displacement Sy is 0. Why? Here there is Sy. Here there is Sy. Here there is Sy. But here Sy is 0. So, Sy is 0. We know that at t equal to time of flight, Sy is 0. Sy is 0. So, I am using the formula Sy is 0, Uy is equal to u sin theta, Ay is equal to minus g. All these things are substituted in this equation. Then Sy is 0 at t equal to time of flight. T equal to time of flight. Then time of flight you will get. Time of flight is nothing but, if you simplify this one, time of flight is 2u sin theta by g. 2u sin theta by g. So, t is equal to 2u sin theta by g. So, u sin theta is equal to uy. U sin theta is equal to uy. So, time of flight is 2uy by g. Time of flight purely depends on vertical component of velocity. It is independent of horizontal component of velocity. You have to remember this point. Okay? See, maximum height. When body reaches highest point, the vertical displacement is called as maximum height. Maximum height is Sy. Sy when it reaches highest point. So at highest point already we know that, the vertical component of velocity Vy is equal to 0. Vertical component of velocity Vy is equal to 0. Now, the height at which vertical component of velocity becomes 0 is called maximum height. So, Uy is equal to u sin theta. Vy is 0. Ay already, Ay is minus g. Sy is maximum height. You know one formula, Vy square is equal to Uy square plus 2Ay Sy. I am using the formula V square minus U square is equal to 2As along the y direction. So, Vy square 0, Uy is u sin theta whole square minus 2, Ay is g minus g, Ay is minus g, Sy is h maximum. From that Sy is h maximum, that is equal to h I am saying. So, h is equal to, if you simplify h maximum here, you will get the u square sin square theta by 2g. That is nothing but u sin theta is vertical component of velocity. So, u sin theta is equal to uy square by 2g. So, what maximum height also depends on vertical component of velocity. Time of flight also depends on vertical component of velocity. They are independent of horizontal component of velocity. Right. Horizontal range. The horizontal distance travelled by the projectile during time of flight is called horizontal range. Horizontal range. So, we know that along this direction, the displacement, horizontal displacement during time of flight, that means Sx is range if t is time of flight. If t is time of flight. So, we can write that Sx is, let us take Ax. So, x is equal to uxt plus half axt square. I am using the formula s is equal to ut plus half at square, but along x direction. Sx is ax, that is equal to r, ux is equal to u cos theta, ax is 0, t is time of flight. Now, r is equal to ax is 0, now ux is u cos theta, t is time of flight. So, but time of flight is, we know, already derived, 2u sin theta by g. So, range is equal to u cos theta into time of flight 2u sin theta by g. I am substituting these values. I got 2u square cos theta sin theta by g. But 2 sin theta cos theta sin 2 theta u square sin 2 theta by g. So, we can write, here we can write u cos theta is ux, u sin theta is uy. So, range you can take 2ux uy by g. 2ux uy by g. Range we can take, because here u cos theta, instead of u cos theta, I can write ux, instead of u sin theta, I can write uy. So, range is equal to 2ux uy by g. We know that range for what angle of projection, range is maximum. Same velocity, I am projecting the body with velocity u, constant velocity u, but I am changing the angles. I am changing the angles. At a particular angle, range becomes maximum. The range becomes maximum. How I can calculate? We know already range formula. In the range formula, u square sine 2 theta by g. So, range is directly proportional to sine 2 theta. Range is maximum if sine 2 theta is maximum. Sine function maximum value is 1. So, sine 2 theta is equal to 1. Then sine 2 theta is equal to sine pi by 2, because sine pi by 2 is 1. From this, 2 theta is equal to pi by 2, theta is equal to pi by 4. So, range is maximum when angle of projection theta is pi by 4 or 45 degrees. When body is projected by making 45 degrees with the horizontal, it goes to the maximum range, maximum horizontal distance it will travel for a particular velocity. What is that maximum range? What is that maximum range? That is equal to, this value is 1. This value is 1. So, u square by g. That is the maximum range. See, I am discussing one problem based on this. A body is projected from ground with a velocity 3i plus 10j meters per second. Find the maximum height attained and the range of the motion. So, here g value is 10 meters per second square I got. So, you can take velocity is 3i plus 10j. So, Vx is here comparing this velocity. I am comparing this velocity. I already write that u cos theta I plus u sin theta j. That is the initial velocity. U cos theta is initial velocity along x direction, that is 3. U sin theta is Vy, that is equal to 10 meters per second. I want the maximum height. Maximum height only depends on vertical component of velocity Vy square by 2g. I am substituting Vy square is 10 square by 2 into g, that is 5 meters. So, maximum height reached by the body. Maximum height reached by the body is 5 meters. Range. Range already we discussed. Range is equal to 2ux uy by g. 2ux uy by g. 2 into Vx is ux. Ux is how much? 3. Uy is Vy 10 by g is 10, that is 6 meters. Range is 6 meters. Height is, I got the 5 meters. Okay. See, height is 5 meters. Now, here two bodies are thrown up angle 45 degrees, 60 degrees with horizontal. If bodies attain the same vertical height, height reached by them is same vertical height. Vertical height is same for both. H is equal to, first one u square sin square theta by 2g. You know that h1 is equal to h2. They are giving that. If the bodies attain the same vertical height, find the ratio of velocities with which they are thrown. G equal to 10 meters per second square. Heights equate किया मैं. So h1 is equal to h2. h1 is u1 square sine square 45 by 2g. h2 is u2 square sine square 60 by 2g. So u1, I want to find out the ratio of their velocities. So u1 square by u2 square, I am substituting sine square 60 is root 3 by 2 whole square by sine square 45 1 by root 2 whole square. I substituted, I got 3 by 2, u1 by u2 value, I got root of 3 by 2. See, equation of the trajectory of a projectile, very, very important. Trajectory is path followed by the projectile. Trajectory is path followed by the projectile. Suppose it is going, I am projecting with velocity u by making some angle theta. Then it is following this path. This path equation I have to find out. Okay? So, let a body be projected by making an angle theta with velocity u. Displacement body reaches at this point. This is Sx, this is Sx, this is Sy. I am saying that Sx is equal to x, Sy is equal to y. Then along the x-axis, displacement I am writing, x is equal to uxt plus half axt square. You know that ux is u cos theta for a projectile. This is very, very basic point. Ax is 0. I am substituting all these values. I got that x is equal to u cos theta ax. This term is equal to 0. Now, along y direction, displacement y. That y can be determined. Y is equal to uyt plus half ayt square formula I am applying. Uy is equal to u sin theta, ay is the minus g. So, y value is u sin theta t minus half gt square. Now, from this equation, I am taking t value. T value is how much? T value is x by u cos theta. I am putting the t value in this equation, u sin theta into t value x by u cos theta minus half g into x by u cos theta. Here t value I am substituting whole square. I got y is equal to tan theta sin theta by cos theta, tan theta u will cancel, tan theta x minus gx square by 2u square cos square theta. This is the equation. This is the equation. This equation is in the form of y is equal to ax minus bx square. What is a here? Here a is equal to, tan theta, b equal to g by 2u square cos square theta. Okay? Then this is y equal to ax minus bx square. It is equation of a parabola. It is equation of a parabola. So, the trajectory means path. The path followed by a projectile is a parabola. It represents the parabola equation. Y equal to mx represents straight line equation. Similarly, y equal to ax minus bx square represents parabola equation. So, now I have to express this equation of the trajectory in terms of range of projectile motion, So, I have already derived this y is equal to x tan theta. minus gx square by 2 u square cos square theta. So, x tan theta I am taking as common, 1 minus gx by 2 u square cos square theta tan theta. So, y is equal to x tan theta 1 minus gx 2 u square cos square theta tan theta I can write as sin theta by cos theta. So, x tan theta 1 minus gx by 1 cos theta will cancel 2 u square sin theta cos theta. So, this is y is equal to this value u square sin theta cos theta is u square 2 sin theta cos theta, 2 sin theta cos theta is sin 2 theta by g. But we know that range is equal to u square sin 2 theta by g. I am substituting this u square sin 2 theta by g here. I got that y is equal to x tan theta into 1 minus x by r. This is the formula. It is included range and horizontal displacement. This horizontal displacement x and range are included here. If range is given, horizontal displacement is given, angle of projection is given, then vertical displacement can be calculated by using this equation. So, I am giving one example for that. The equation of trajectory of a particle is given as y is equal to root 3x minus 5x square. Find the angle of projection. So, just I am converting this equation in terms of y is equal to x tan theta already derived previously, x tan theta into 1 minus x by r. How I converted? Y is equal to, I am taking root 3x common, 1 minus 5x square by root 3x. So, y is equal to root 3x 1 minus 1 x will cancel 5x by root 3. So, y is equal to root 3x into 1 minus, you take this one downward, 5 downward root 3 by 5. Now, comparing this equation with our standard equation. What is the standard equation? Y is equal to x tan theta into 1 minus x by r. Then comparing, then what you will get that tan theta, instead of tan theta we have root 3, instead of r we have root 3 by 5, root 3 by 5. So, tan theta is root 3 means theta is 60 degrees, range is root 3 by 5. Now, a particle is projected with a velocity of 10 meters per second by making 30 degrees with horizontal. A wall is present at a horizontal distance root 3 meters from the point of projection. Find the height of the wall such that the particle just grazes the wall. Just it goes in this way. That means it is vertical displacement, y. This is horizontal displacement, x. Okay. Then, x value is root 3 meters, theta value is 30 degrees, u value is 10 meters per second. We know that equation of trajectory is y is equal to x tan theta minus gx square by 2u square cos square theta. I am substituting the values of x here, tan 30 minus g x square value root 3 square by 2 into 10 square cos square 30. So, y value is root 3 tan 30 is 1 by root 3 minus 10 by into 3 by 200 root 3 by 2 whole square. So, I am simplifying this one. So, 30. So, I am getting this 30. Root 3 will cancel 1. So, this value is 150. I got 1 minus 1 by 5. Y is equal to 4 by 5, that is equal to 0.8 meters. So, the wall height can be calculated by just applying the values here by using this formula. y is equal to x tan theta minus g x square by 2 u square cos square theta. So, a projectile is given an initial velocity I plus 2j meters per second. Find the equation of the trajectory. Now, I am taking that its velocity is I plus 2j meters per second, means I means 1I. So, comparing with our equation, standard equation, u bar is equal to u cos theta I plus u sin theta j. U cos theta is ux. I got ux is 1 meters per second. U sin theta is uy. I got 2 meters per. So, this velocity is u cos theta, that is ux. This is uy. Now, so u cos theta value is 1. This is u cos theta value is ux is equal to 1. Uy is equal to 2. So, we know that formula. X is equal to horizontal displacement is u cos theta into t. Already we know that formula. Horizontal displacement x is equal to u cos theta into t, because acceleration along the horizontal direction is 0. Now, see, u cos theta value is 1 into t. So, that is why I am writing that x is equal to t. Similarly, vertical displacement y is equal to u sin theta t minus of gt square. U sin theta is here, u sin theta, that is equal to 2 into t minus of g 10 into t square. So, I got that 2t y is equal to 2t minus 5t square. But t value is x. I am substituting in this equation, this first equation, I am substituting x value here, then y is equal to, we are getting 2x minus 5x square. So, it represents a parabola. It is in the form of y equal to ax minus bx square. Say, here, whenever a body is projected, it is the initial velocity. That initial velocity in vector form is u cos theta I plus u sin theta j. But when it reaches the highest point, velocity is u cos theta I, no velocity along vertical direction. But whenever it reaches this plane of projection, this is plane of projection, ground, then this velocity is in this way. It has horizontal component u cos theta, but vertical component exactly opposite, u sin theta. This vertical component u sin theta, but here vertical component is u sin theta. It is along positive x direction, y direction. It is along positive y direction. It is along negative y direction. Now, that is why this velocity we can write this velocity in the form of u cos theta I minus u sin theta j. Now, I want to find out change in the velocity when it reaches highest point. Initially started here. What is the change in the velocity when it reaches highest point? So, change in the velocity in vector form, delta v is equal to velocity at this point b minus velocity at this point a. So, delta V is equal to u cos theta I minus 0j. Here delta VB is here 0j. U cos theta I plus 0j minus u cos theta initial velocity, here u cos theta I plus u sin theta j, that is delta y is equal to u sin theta, because this u cos theta I cancel, you will get u sin theta j. Suppose they are asking change in the momentum. Newton laws of motion, they will ask the change in the momentum. How you can find out the change in the momentum? That is mass of the body into delta V you have to write. Change in the velocity between point A and C. Delta V is equal to Vc minus Va. Vc at this point velocity we know, u cos theta I minus u sin theta j, minus Va at this point velocity u cos theta I plus u sin theta j. If you simplify this one, you will get minus delta u sin theta j. This is the change in the velocity at any point can be calculated by using these velocities. Thank you.